Today's section is 8.6. It's quotients with radicals. Quotients would be divisions. We're looking at what happens when you get a radical inside a fraction, essentially. Often what this is really called, the process that we're going to be doing, is rationalizing the denominator. If you think of the answers you get when you do a lot of square roots, square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, if you punch that into your calculator, you're going to get a decimal that keeps going forever, and there's no discernible pattern. For most numbers, it's an irrational number. So when we rationalize the denominator, what we're trying to say is we're trying to get that radical out of the denominator so we don't have an irrational in the denominator. Often it helps us simplify the problem a lot more. This is going to be a theme that kind of comes back in pre-calculus and calculus and so on. So you will get more practice later on down the road, but ideally you master it the first time around. Nice thing is, well, for steps, some of you have maybe already been copying them down. But the steps, the first thing we do is simplify the radical. That's what we were just doing in section 8.5. So if you don't know how to do that, check out the 8.5 notes. So it's kind of more practice with that. Then we're going to multiply to get the radical out of the denominator, and then we just simplify. So it's really kind of only one more step. We've been simplifying fractions for years. We just started doing this yesterday. So the new part is multiplying to get the radical out of the denominator. That said, this is a tough section. A lot of people find this to be one of the tougher sections we do this year. Really, you just kind of figure out what step you need to do, and then you just kind of bludgeon the problem into submission, really. Alright, so copy down those steps, and we'll do 3 examples, and that's all. So the examples. First example. We only have numbers inside the radical inside the denominator. You did quick. I have my steps right here, so if you didn't pause the video, you could pause it and quick copy those down. But here's going to be my example, and in hindsight, I should move this down a little bit. Nope, I'm going to leave it where it was. Try to anyways. Alright, so here's my example. So first step we're going to do is we're just going to simplify the radical, and I'm going to do that real fast, kind of assuming that you remember that from before. But this square root of 12, we could break that up into a square root of 4 and a square root of 3. So that really becomes 2 times the square root of 3. So then my fraction becomes 4 divided by 2 square root of 3. And again, if you want the full explanation on doing that, check out the 8.5 notes. Alright, so that's what we did before. We did step number 1, so that's done. Now we want to multiply to get the radical out of the denominator. You could multiply by the whole denominator, but that's just going to give you a lot of extra work in the long run. We want to take and multiply. Well, if we would multiply the square root of 3 by another square root of 3, or multiply the denominator, I should say, by square root of 3, what happens is you end up with, well, 2 times square root of 3 times square root of 3, which is the same as 2 times the square root of 3 squared. And when you do that, the squared and the square root just cancel each other out. So the denominator becomes 2 times 3, or just 6. But by multiplying by 1 over the square root of 3, I just changed the value of my fraction. We can't do that. But we could multiply by the square root of 3 over the square root of 3. Because now what we multiplied by just equals 1, which doesn't change the value of the fraction any. So the denominator we said equals 6. In the numerator we have 4 times the square root of 3. And when you do that, you're never going to combine these numbers in the numerator together. We don't try to figure out stuff there. That radical's already simplified. So step 2 is done. So if you have numbers in the denominator, what I moved it down for originally was you could say multiply by the radical that's left over itself is kind of what I was going to squeeze in there. But now we're done with step 2, and now we have step 3, simplify the fraction as much as possible. Because this is connected by multiplication in the numerator, it's treated like it's one term. So we look at, well, what goes into 4 and goes into 6? Well, they're both even, so we could divide them both by 2. That would give us a 2 here and a 3 here. Then you could say, could we simplify any more? Nope. And we're done. So the final answer then is 2 times the square root of 3, all divided by 3. And I just want to make one comment. We can't reduce here. because the 3 is inside the radical. You never be able to reduce something inside a radical with something that's not inside the radical. If you really stink at reducing fractions, or if the numbers are quite a bit harder, what you could do is you could pull up a graphing calculator, and I'll get rid of my key press history too. You could do that same thing. So if you have 4 divided by 6, you could do 4 divided by 6. And if you press your math button, which is over on the left side, your top option, number 1 there, says change it into a fraction. So press enter to select number 1, and it'll give you the 2/3. With the older operating systems, it'll actually write it this way. For your answer, it'll say 2 divided by 3. But that is an option that'll get you reducing a little bit easier. Alright, so that's the example. What do you do when you just have numbers? If we take and have variables, there's a little bit more steps to it, but it's really the same sort of thing. So let me add here. So first we're going to simplify the radical, multiply to get the radical out of the denominator, and then simplify the fraction as much as possible. So simplifying my radical there. First step when we had one like that was just to take and do the 45. So 45, half of that's going to be 22.25, 22.5. 22.5. Okay, focus. So then anything smaller than that that's a perfect square is an option. So 45 divided by 16 gives you a decimal. 45 divided by 9 works. So we could break that up into a 9 and 5. So my 45 becomes 3 times the square root of 5. Left a little space, because now that we have a square root there, square root, we could say, well, how many of these x to the 5th can we pull out? So we're doing multiples of 2, 2, 4, 6, so 2 multiples. We could pull out an x squared. That takes care of 4 of my 5 x's, so then we'd have the new denominator being 3x squared times the square root of 5x. So this then would equal 3x squared, square root of 5x. And we just did step number 1. So you could mark that off. That's all over 6x. Some people like simplifying right now. I'd say wait until the end. Otherwise you're going to have to simplify a second time around. But just like before, we multiplied by what was stuck inside the radical. We do the same thing again here. That we want to get that square root of 5x out of the denominator. So we multiply by the square root of 5x over the square root of 5x, which is the same as just multiplying by 1. So we can do it and not change the value of our original fraction any. These two radicals here become square root of 5x squared, so the radical just drops out, leaving us in the denominator. We have our 3x squared from before, and the square root of 5x and square root of 5x just becomes another 5x. And in the numerator we have 6x times the square root of 5x. And what's in the radical, because that's as simplified as it gets, we just leave that alone. It's as good as it's going to get. Now you could combine, some people like to combine this in the denominator and get 15x to the 3rd and then go from there. I like just, well, we could cancel this x. That x is going to cancel with one of these. You could either make this 3x times 5x. I'm just going to have it cancel out that x because they're both to the 1st power. And then we could look at the 6 and the 3. 6 over 15, it's easier just to say, well, I'm going to divide this by 3, get 2, divide this by 3 and get 1. Or you could do 6 divided by 15, math, enter, enter on your calculator. And let's see what we have left. So I have 2 times the square root of 5x in the numerator. In the denominator I have 1 times 5 is 5. Then I have an x squared. Alright, last step is just make sure, usually if people make mistakes, either they're totally lost or they just didn't simplify enough. So it's always good to kind of check again. 2 and 5, no number goes into both of those. They're not both even. And when you have something in a radical, you never can simplify something in a radical as something that's not. So that should be our final answer. The very last kind of problem is going to be, what do we do if we have plus or minus in the denominator along with some numbers and variables and such. If you need to pause it to copy down the title, go for it, but I wouldn't copy down this example. I'm really just trying to prove a point with the example. And I was pausing to give you a chance to write it, but I just told you to pause the video. Alright, if you think back to complex numbers, imaginary numbers, that stuff, when we had division with a complex number, a real and an imaginary in the denominator, what we ended up doing was multiplying by the complex conjugate. So in this case we had a 6 plus I here, so we multiply by 6 minus I. And the reason we did that is when we FOILed, we had our 36 from the first, then the outside and the inside will always cancel out. That the outside was minus 6i, inside is plus 6i, those are gone. Then we ended up getting a minus an I squared, which then we could change that to a negative 1. Well, if you take and instead of this I, look at that as being a radical, you're going to get the same sort of thing happening. So I'm just going to try to squeeze a radical and maybe an x in there. We'll actually do this for real and write it down soon. But when you go through and FOIL this, you still get the 6 times 6 is 36. The outside and inside will still cancel, because now we have 6 square root of x minus 6 square root of x. And now, before we end up with I squared, well, if we have a square root of something squared, that square root's going to drop out. So essentially what we're doing is we're multiplying by that same thing. It's not the complex conjugate, because it's not a complex number, but it's really that same type of problem. So my example here then is going to be 5 over 6 plus the square root of x. I'll add my little square root of x there. So this is the example that you should write down. Now, we multiply, like we just said before, times, I don't know if you could call it a conjugate officially or not, but 6 minus the square root of x over itself. So 6 minus square root of x over 6 minus square root of x. And we still need to FOIL. But as long as the numerator is pretty simple, and in our book it is, numerator is always pretty when you have to do this kind of problem. Alright, on the top we just distribute. So we do the 5 times the 6 and the 5 times my radical. So 5 times 6 is 30. And then we have 5 times, you could kind of look at it as though it's negative 1 square root of x. So 5 times the negative 1 is minus 5 times the square root of x. In the denominator, if you know what you're doing, you can simplify it and don't write it all out. I'm going to go through and do all the steps. So I'm going to FOIL in the denominator. So the F stands for first, so 6 times 6 gives me 36. Then the outside and inside is what I'd skip if I wasn't trying to show it to you. So we have a positive 6 times a negative 1 square root of x, so minus 6 square root of x. Then we do the insides, we have a plus 1 times the square root of x times 6. So that'll give us 6 times 1, positive 6 times square root of x. Now we go through and do the last. We have a positive 1 square root of x times a negative 1 square root of x. So positive times a negative will give us a negative 1. Square root of x times square root of x is square root of x squared, which then I wouldn't fault you at all if you just wrote that as an x. Actually, I'm going to go back and just say minus. That just simplifies and becomes an x, because the square root and the square will cancel each other out. The whole reason for doing this is we have a minus 6 square root of x plus 6 of those square root of x's, so our outside and inside will drop out. And like I alluded to before, feel free to not even write that as you do the problem, as long as you know what you're doing. Now in the numerator we have 30 minus 5 square root of x divided by 36. This minus disappeared with the outside and inside canceling, but we still have this minus x. Now in order to reduce, you can take and break this up into two different fractions, but if you did that it'd have to look like this. You can't break up the denominator. So 30 over 36 minus x, and then a minus from that minus right there, 5 square root of x over 36 minus x. So if you want to be able to reduce, you need to at least be able to pull something out of both parts of the denominator and something in the numerator. So if you look, they don't all have a number, so we can't reduce the numbers. They don't all have an x, so we can't reduce that. Here we just treat this like one clump. And same thing, they don't all have a number to reduce. Where if they don't have a number to reduce, they don't all have an x, so we can't simplify it at all. This is where we'd end. Where we could simplify, where we could have simplified, would be if this here was maybe something like a 2x. Then we could have simplified this part of it here, but chances are because this is an odd number, we wouldn't have messed with it. I probably should have just kept my mouth shut. That's the end of the notes from section 6.